Hello everyone, this is Michael Hicks with your Business Admin 602. We're going to start today a couple of short lectures on the idea of elasticity, and I'm going to use what you see before you, which is I appear a bit grainy to you, is because I'm working with a light board which I've constructed that allows me to provide you instruction as if we were in a classroom and you were seeing a board. And so we're going to go through that graphics here, and we're going to be doing it more slowly, or at least in smaller chunks, because while this light board provides a lot of good information, it also fills up pretty quickly, and so I feel obligated to take a break and clean it off and move to the next one. So just let me begin. Elasticity is this concept in economics of the response of a quantity supplied or demanded in response to price. That's what you'll most normally see it as. There are also other examples. I'll show you an empirical example of tax-based elasticity, or the elasticity of taxes with respect to a tax base. So how much do tax revenues for personal income change, for example, or on income tax if personal income changes. And so I'll just go through some ideas on this and how this works. And we begin really with a supply and demand graph, and we have price and quantity here. We have a supply curve that's upward sloping, a downward sloping demand curve, right? And elasticity, if we were to compare two identical graphics, one that looks like this and then another that has a demand curve that looks like this, it's a lot flatter, right? Assuming the scale is identical, then this demand curve would have a more elastic response. And by that we mean if the price changed from this price, right, we'll pick the same price, and dropped to this price, we'll call this P and P sub 0, we go to P sub 0 here, then there is I'll clean this up a bit, a much bigger change in quantity. In this case, you go from Q sub 0, or excuse me, just bring Q to, and I'll eliminate that so it doesn't confuse you, to Q sub 0, and here you go from the original Q to here to Q sub 0, and then I'll just label both of these so you can see. And so that means in this example here, which I'll star, right, this is a much more elastic demand curve. If we go, and so this is higher elasticity, we could provide another example with a demand curve that was very flat. And in this case, right, if we went from price P to price P0, there is a very small change, Q to Q0 and P to P0. So we're talking about this roughly the same. I'm intending this to be the same shift in each of these, but the amount of quantity that changes is very different. And so we express this as an elasticity measure. We usually call it demand, right? And it's always going to be negative. And this is one of the things that economists often get wrong. It's always going to be negative. That elasticity for demand is going to be negative. That's not true with elasticity of supply. So when we talk about elasticity, we usually refer to it in either we're sloppy and just ignore it, or we make it absolute value terms. But elasticity is the percentage change in quantity divided by the percentage change in price, right? So every item is going to have an elasticity that ranges from 0. This is something that's completely unaffected by a change in price, right, up to 1, and then up to infinity, right? So elasticity takes this range in absolute value terms. So how to think about this? How to think about this range of elasticities? elasticity that is perfectly inelastic at this range, right? At elasticity is equal to 0. Price does not affect demand for it. So think about insulin or heroin. That a doubling of price will have no effect on the amount of these items consumed. Then we have an inelastic range when we go from 0 right up to 1. 1 is called unit elastic. So a 1% increase in the price will result in a 1% decrease in quantity demanded. So that's a movement along this slope here. If this is 1%, this is 1%. In this example here, we have inelastic. So if this decline is 1%, this decline is much less than, or this increase here is 1%. And again, it's negative because it's a negative value along that slope of the demand curve. And so this is what we call inelastic. If there's unit elastic, that's just really the transition point between inelastic and elastic. You rarely find unit elastic items. Then we have an elastic range. An elastic range is, sorry, I'm spelling poorly today, elastic. That's where the absolute value of elasticity is greater than 1. And in this perfectly elastic range, for example, in demand, if the price goes up by 1%, sales will drop by more than 1%. Or, as illustrated here in this example, as price drops by 1%, sales will increase by more than 1%. So why is this important, and why are we talking about it in this class? Well, if you're in business, a significant part of business is going to be determining what is the profit maximizing price for your company. And so if you're sort of coming from the engineering background, there's a lot of effort gone into picking what a profit will be and then adding that on to the cost of doing business. But in reality, cost can vary profoundly. And we'd want to know, given a certain product, what could we do? What would be the variability in price that we could be profit maximizing? And we may care about this in the long run, or we may care about it in the short run. Just like how do we profit maximize in the next 3 months, which goes over Christmas, may be a very different answer than how we profit maximize in 3 years, and we'll talk about that in a later chapter. But elasticity here, if we had a product that was in the elastic range, if we dropped price by 1%, sales would increase by more than 1%. So all things being equal, if we could reduce the price in it from the elastic towards the inelastic range, our revenue would grow. Not necessarily profit, but revenue. Same thing if we're in the inelastic range, if we could raise revenue, if we raise the price in an inelastic range, we don't lose as much of sales as we do. The change in sales is less than the percentage change in price. And so businesses are interested in understanding what their elasticity will be, how this works, and so they oftentimes spend an enormous amount of effort in trying to determine optimal price. And this is done in advertising, it's done in retail sales, it's done in online advertising, it's done in a lot of different environments where businesses vary the price to try to determine what is most optimal in terms of profit maximizing. Excuse me. Talking to a board it builds up a lot of CO2 in here, a lot of carbon dioxide in here. And so what you would need to consider is if you're applying the elasticity measure to your business, that this would influence choice of sales, choice of how you separate consumers by type. Do you offer a discount for elderly people? Do you offer a child meal? Those are ways of capturing variable elasticities across consumer segments. So coupons, occasional sales do the same thing, and your elasticity changes at different seasons. So if you were to buy, a lot of people have started buying gift cards for Christmas because they know the price on those sweaters and jeans that you may give your kids will drop right after Christmas. So the day after Christmas, a kid could take a gift card into the store and really plus up on clothes. And so this basic elasticity argument, this discussion of elasticity, sets up almost all of our empirical considerations for much of the rest of the class. That what we've done heretofore in economics is being theoretical, and we show some examples. This model gives us more information, and I'll do this along with some information available to you from our guest lecturers, Jody and Alex, both of whom I know who are very good at describing this. So you get 3 different good ways to think about elasticity. And again, this is a key part of any business enterprise that involves pricing. Thank you.